let's do number 11. And then I'm going to do this on a separate sheet of paper so it's easier to see. So I have to write bigger and people can actually see better. All right, so here, once we cover this problem, then we can move on with just using this. All right, so what is the percent uncertainty? So for number 11, percent uncertainty. Okay. Basically can be written as um, you could think of it as measured, right, minus the actual, okay, over the actual. Now this can be switched obviously because this is an absolute sign, so you can make it actual minus measure over actual, same thing. But important thing is you have to divide that by actual. Okay, Andy?
Yeah, is percent uncertainty just like the same thing as percent error?
Yep, absolutely, exact same thing. Yeah, exact same thing. So that's what we're going to have to work on. However, when we have uncertainty in the radius and we do mathematical operation with that, then that uncertainty of error, it amplifies much bigger, it magnifies to a much bigger thing. So here, when they ask us to find the percent uncertainty in volume of a sphere, spherical beach ball, right? That's huge beach ball. That's like OMG. That's like 12 foot in radius, and that's huge. That's 24 feet. I don't think you could even fit that in the classroom. Well, anyway, so here, if I were to look at a spherical beach ball, okay, with radius r, the volume of a sphere in general is 4/3 pi r cubed. Okay, but we are given that our radius is equal to, okay, our radius is equal to 3.86, right, plus or minus 0.08 meters. Now, this is the uncertain value right here. This is the tolerance they gave us, okay? So we really don't know what they used to measure this, but whatever the measuring instrument they used, this was the given tolerance, all right? So without the uncertainty, my radius will be simply just 3.86 meters, okay? With the uncertainty, so r plus will be this plus that, all right? So it will be 3.94 meters. And of course, r minus is equal to 3.78 meters. But we're not going to use the minus. We're just going to use the plus. You can use minus if you want to. Like if you want to make sure it doesn't fall out, then you use this term so that whatever hole you make will be exactly for this spec so it doesn't fall out, right? But if you use with this spec, the hole that you make will fall out because you still have, you know, uncertainty. And then we will use this as our given actual radius. All right. So let's take a look at the volume of R naught, right? So here, when we were using this, it is volume naught is equal to 4/3 pi r naught cubed, right? So that is equal to 4/3 times pi times 3.86 cubed. Okay? So when we calculate this volume with R naught, then it becomes something like 240.908, okay, meters cubed. All right, so it's good to know that, because this is sort of like we could think of this as like actual, right? And with the uncertainty tolerance, so let's take a look at R plus, okay? And then we will use that R for the volume. So volume for plus is equal to 4/3 pi r plus cubed. So for the volume plus happens to be 4/3 times pi times, right, 3.94 cubed. And if you work this out correctly in your calculator, so volume plus comes out to 256.199 meters cubed. All right. So what is the uncertain value? So that uncertainty is equal to, is simply just the absolute value, okay, of volume plus minus the volume naught. Right? Again, this can be switched. It doesn't matter, right? This can be switched because it's an absolute value sign, right? So the uncertainty of the volume, right? Uncertainty. So volume uncertainty is equal to, right? 256.199 minus, right? 240.908. Okay. Boom. So the volume uncertainty comes out to 15.291 meters cubed. So if you really want to think about writing the volume, the new volume with the uncertainty, right, can be written as follows, okay? 240.908 plus or minus 15.291 meters cubed. All right. So this would be the volume with uncertainty. We're not done yet. We're looking for the percent uncertainty now. All right. So the percent uncertainty, right, is equal to, oops. So we have volume plus, this is minus now, minus volume naught over volume naught, right? Times 100%. Therefore, volume naught, I mean a volume plus is 256.199 minus, right, volume naught, which is 240.908, divide by 240.908. So the percent uncertainty, oops, wrong color. The percent uncertainty for the volume is equal to, right? I think you get something like, well, you know what this is? This is basically that, right? So it's like 15.291 over 240.908 and times 100%. And I think it comes out to like 6.35% uncertainty. Okay? So from uncertainty of the radius, right, of 0.08 meters, right, you get 6.35. So how much of uncertainty percent is just for the radius? If you were to look at that, then 0.08 divided by 3.86, right? If you multiply that by 100, so the radius had uncertainty of only like 2.1%. But when you work this out, you're going to get like 6.35% of uncertainty when you were looking for the volume of it. Now, most likely, the area of a circle will be probably a little less than 6.35. So it's going to be somewhere between 2.1 and 6.35%. All right. So it's not going to be linear. So there's probably some other factors involved. Okay. So when you have uncertainty, it will get magnified when you do operation on it, especially when you're looking for the volume or area or other things with it. All right. So that's pretty much what it is for the last problem of your homework packet. Any questions? All right. Then let's move on to the light year problem, because that was pretty important. All right. Here it states a light year is a distance that light travels in one Earth year. Now, light travels very fast. Just to let you know, the light travels 299,800,000 meters in 1 second. Okay? So, if the speed of light is 2.998 times 10 to the 8th meters per second, we can pretty much figure out how much it travels in 1 year if we know the time in seconds for 1 year. Right? So 1 year. Now, if we multiply this, the seconds will not cancel out. So we have to convert this 1 year into seconds first. All right. So since distance is equal to, right, speed times time, right, we have to have this in the correct unit. So let's multiply this 1 year by 365.25 days in 1 year. And then, of course, there are 24 hours in 1 day. And then there are 3,600 seconds in 1 hour. So if we work it out, notice how years would cancel out, days would cancel out, hours would cancel out, and giving us our time in seconds. So if you work it out, your time is equal to, I think you get something like 3.1558 times 10 to the 7th seconds. This is how many seconds there are in 1 year. Therefore, right, in 1 light year, right, which is a distance, 2.998 times 10 to the 8th meters per second times this many seconds. So, as you can see, the seconds will cancel out, giving us our light year in meters. And this comes out to 9.461 times 10 to the 15th meters. Now that's a lot of meters. It's like that's like 9.5 with like 15 zeros, right? 15 zeros. So 1 light year, right, is equal to 9.461 times 10 to the 15th meters. Well, once we know that, we can move to the next one. How many miles will that be? Well, we already know how to do this. So now that we know 9.461 times 10 to the 15th meters is 1 light year, so if we could convert that into miles, by saying there are 1,610 meters in 1 mile, right? So if you work that out, I think you get something like 5.876 times 10 to the 12th miles. That's a lot of miles. Talk about some frequent flyer mileage there. Yeah. Wow. Well, let's fly it out there. Let's say instead of like being a light, let's say we're going to try to fly out to 1 light year distance on a commercial jet airliner. Right? We did something similar to this with flying out to the sun, remember? But if we were to fly out 1 light year out from Earth, let's see how many days it takes. Right? How many days does it take? So first, we know, speed is equal to distance divided by time. So since we're looking for days, we're looking for time, right? Time is equal to distance divided by speed. So if we were to say distance is 5.876 times 10 to the 12th miles, and then we divide that by speed, right, which is 600 miles per hour, right? All right. So, notice how the miles will cancel out and hours will go on top. Okay. So this will give me, ready for this? 979,396, right? 3230 hours. Holy shnikes. That's a lot of number. And I have no clue. I know it's just big, but I have no clue how long that is, really. Because that's a just ridiculous amount of hours that I'm going to be on that airplane, right? Well, let's put it more in terms so we can understand, how really long that is. Let's convert that into years, right? Well, let's convert that into days. So 9,793,963,230 hours, and in one day there are 24 hours. So if you work that out, you're going to get 4.08 times 10 to the 8th days. Still doesn't give me any clue how long that is. I know it's a big number too, right? But if we were to convert this into years, right? So 4.08 times 10 to the 8th days, we convert that into 365.25 days is equal to 1 year, right? It'll take us more than 1 million years to fly out to 1 light year on a commercial jet airplane, right? It'll take more than 1 million years. That's really far out, right? That's really, really far out. All right. Any questions?